Okay, so here I've got a triangle solver. So this is a practice video for trigonometry. And what we've got to do is we've got to draw 6 triangles. Now for A, B and C, we have to roll 2 dice, okay, to add 2 side lengths to a right angled triangle. And we've got to make sure, it says in brackets, that the hypotenuse is greater than the opposite adjacent. Okay, for D, E and F, we've got to add one side and then randomly decide on a second angle. So it's got to be less than 90 degrees, so we'll need a random generator for 1 to 89, 1 to 90 will do. Okay, that's fine. Now complete all sides and angles. So here's the diagram, the basic idea. We've got a right angled triangle, not drawn to scale obviously, and we've got missing side lengths and missing angles here. 1, 2 missing angles. Okay, let's give this a go. So first of all, let's draw let's draw A, B and C to start with. Okay, so there's B and C, and now let's fill in A. Let's have this one as B and C. Okay, so what have we got to do? For A, B and C, roll 2 dice to add 2 side lengths. So here we go. So we've got 8. So 8, I'm going to make the hypotenuse. It doesn't say which I'm to use. What it does say is the hypotenuse has to be the largest one. So let's see what we get next. Well, that says 4. So let's make this our side length there. Let's do it again for B. So we've got 7 this time. Then let's go down here. 1 and 3 is 4, so that will go there. So now we've got a missing hypotenuse. For C, let's see what we get. Okay, 6. Let's go for this side here. And finally, well, it's greater than 6, so we'll put 8. So it's 8 again, and we'll put that here. Okay, we're ready to go. So all we've got to do now is fill in the angles and the side lengths. So how are we going to do that? Well, before I start, I'm going to just write, let's use a different kind of pen. I'm just going to write my little mnemonic, because I know I'm going to need it. It's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA, SOHCAHTOA, and that's the standard way for remembering these ratios. So now if I begin with this angle here, I've got 2 of my missing side lengths. I've got 4 and 8. Well, what are these? This one here is adjacent, and the longest opposite the right angle is the hypotenuse. So I've got the adjacent over the hypotenuse, so it's going to be this K here. Cosine, in other words. So I'm going to use cosine to find my angle, but if I'm finding an angle, it's going to be an inverse cosine that I'm going to use, or arc cosine. So 4 over 8, let's just write inverse cosine of 4/8. Well, 4/8 is 2/4, and 2/4 is 1/2. Okay, so let's just write 1/2. So inverse cosine of 1/2 is going to give me what? Well, you should know this off the top of your head, really, because what we seem to have here is a 30-60 triangle. Let's just check on the calculator though. So we've got inverse cosine of 0.5, and it does indeed give me an angle of 60 degrees. There we go. So I could fill in here 60 degrees. Okay, that's the first one. Now, if I've got an angle of 60 degrees and an angle of 90 degrees, then to complete my angles, I simply need to subtract 180. Sorry, I take 180, the sum of the angles in any triangle, subtract 60, gives me 120 degrees for my second angle. Sorry, subtract 60 and subtract 90. Little mistake there. So it's not 180 degrees. I'm always going to be subtracting 90, which is the right angle. So actually it's 90 degrees. Subtract 60. There we go. Good job I spotted my mistake, but fairly easy to spot because 120 obviously is not going to work at all. So there we go. 90 degrees subtract 60 gives me 30 degrees. So I can now fill in that angle there. Excellent. Now, what about my missing side length? Well, for the easiest thing to use, in fact the only thing that I'd want to use here, I could use the trig ratios, but I'm just going to use Pythagoras, I think. So I've got 8 squared, okay, equals, let's call this x. So 8 squared is the hypotenuse, equals x squared plus 4 squared. So if I subtract 4 squared from both sides, I get x squared equals 8 squared minus 4 squared. Therefore x squared equals, well, 64 minus 16. Now, 64 minus 16, we don't want to make a mistake here. So if I increase the second number here, the 16, if I increase that to 20, then either side of the minus sign we must increase them both. So if I increase that by 4 to 20, then I increase that, I'd end up with 68 minus 20, so that's 48. So x must equal the square root of 48. Now let's have a look at that just for a moment. I'm looking for squares so I can simplify this third. Now I've got 4, so that would give me root 4. Let's just think there. Have I also got 9, 16? Could I do that? 3 16s are 32, 40, 3 16s. So I could say this is also the square root of 16 times 3, giving me x equals, so the square root of 16 is 4. And so that takes it outside of the square root sign, and I end up with 4 root 3. So that's a nice little simplification. So my missing side is 4 root 3. And that completes this one. Okay, now for part B. So I've already randomized my side, so I've got a 7 and a 4. So all we've got to do is use Pythagoras to complete the missing side. So let's just write it as c squared minus, equals. So if this is c, a squared plus b squared. So c squared, if the hypotenuse is c, gives me, well, let's say 7 squared, so 7 squared plus 4 squared. Well, 7 squared is 49 and 4 squared is 16, so c squared equals 49 plus 16. we can make those into nice numbers. So 50 add 15, so c squared, or let's just say c equals square root of 65. Good, so that's got my missing hypotenuse. So my missing hypotenuse is 65. Let's put it inside there so it's not going to get in the way. So my hypotenuse is 65. What about my missing angles? Well, let's go for this one first. Okay, so I'm going to use the easier numbers here because root 65 is obviously a little bit complex. So let's look for my adjacent. So there's my adjacent there. And there's my opposite. So now go up to my mnemonic. I'm looking for adjacent and opposite. Opposite over adjacent is going to be better. I don't want cotangent, so I want tangent is opposite over adjacent. So that's going to be 7 over 4. So I'm looking to use an inverse tan of 7 over 4. Okay. Well, reaching for my calculator, first of all let's get 7 divided by 4 and see what that is as a decimal. Well, it's 1.74, isn't it? I don't even need to use my calculator for that. So I go inverse tan of 1.75 and I get 60.255. Okay, so what I'm going to do is round to the nearest degree. In other words, what I've got here is 60 degrees again, roughly like that. But I need to note down that I've rounded to nearest degree. Okay, and I'm going to just check what happens when I subtract from 90. 90 subtract 60.255 is going to give me, what's this? Okay, 29.74. So again, to the nearest degree, that's going to be 30. So if I put my missing angle in here, so I should just note down here that 90 degrees minus 60.255. Well, I'm not going to have room, so let's just keep it as minus 60 degrees. Okay, there we go. Equals 30 degrees, and that's completed that triangle. Okay. Now for C. Okay, let's take a slightly different approach here, just to mix things up a little bit. Let's not go for Pythagoras straight away. Let's go for this angle here. Okay. And how are we going to work that out? Well, we've got opposite. Okay, let's just draw an arrow so you can see that very clearly. We've got opposite over the longest side, which is 8. 6 over 8. Well, that's going to be 3 over 4, so I can immediately see that's 3/4 or 0.75. And if we've got opposite over hypotenuse, then we're talking about the sine function. So I'm going to take the inverse sine, like that, of 3/4. And let's see what that gives me. So the inverse sine of 3/4 gives me 48.59. So that's my angle. Let's just put it here so that we give ourselves plenty of space. Okay. There we go. 48.59 degrees. Now I'm not going to fit that in. Let's say to the nearest degree it's going to be, so to 49 degrees. To the nearest degree. Let's just write that underneath. Nearest degree. Okay. Now, I'll keep that though as my value because it's more exact than just rounding it to the nearest degree. Let's use my calculator again to subtract from 90 and I get 41.41. If I add that together, would that make 90? 48.59 plus 48.41 would, yes, add up to 90. So I can say my missing angle here to the nearest degree is going to be 41. Okay, 41 degrees. Okay, all I've got to do now is use Pythagoras then to complete my missing side. Okay, so by Pythagoras c squared, well that's going to be my, let's just put Pythagoras, Pythag here. Okay, so c squared, we've got 64 equals 6 squared, so that's 36 plus x. Don't know why I abbreviated that. Let's go like that. So x equals, if I subtract 6 from both sides, I've got x equals 64 minus 36. Again, easy to make little slips here. You can use your calculator obviously, but you shouldn't need to. If I think of what would I add to 36 to make 64, that would be 28. Yeah, 28 add 36 would be 64. So x equals, sorry, x squared, I should say. X squared equals 28. So now I take my square root. Well, if I think of 28 as 4 times 7, so I can say it's the square root of 4 times 7, then x equals 2 root 7. So I can fill in my missing side. Let's put it inside the triangle. 2 root 7. Okay, so now to move on to D, E and F. Okay, so I just paused the video because what I wanted to do was get some random angles, because for D, E and F we've got to add one side and randomly decide a second angle which has got to be less than 90. Now what you need for that is a random 1 to 90 generator, which you can get on the internet, and you can just simply randomize that or just make up some numbers. Anyway, I've used the random generator and I've got these angles. Let's draw our triangles first. So let's draw, we should be able to squeeze it in there and here. There we go. Label them D, E and F. Okay, so we got D, E and F. Oops, that one didn't quite complete. Let's just see if we can complete it. There we go. Okay. Now, what I've got is an angle of, let's put them up here for a change. So we've got 46. So that was my first randomly generated number. Let's look at 45. That can go down here, that'd be fine. It doesn't quite look like 45, but near enough, and these aren't drawn to scale. And for F, I've got 75, so that's got to go down here, okay, to be even remotely plausible. So there's my 75-degree angle there. Now I need to generate some side lengths. So I've got 10. Let's put 10 here. Okay, let's roll again. I've got 3. Well, that's interesting. Let's put 3 down here. And for F, what do I get? I get 11. Okay, so where am I going to put 11? What haven't we used? Let's use the hypotenuse. So the hypotenuse can be 11. Very good. Let's complete these examples then. So for D, I've got 46 degrees, I've got a side length of 10, and of course I've got my 90 degrees for my right angled triangle. So what can I do first? Well, first of all, I can complete my angles, because I know that the angles of a triangle sum to 180 degrees. So if I write 180 degrees minus 46 gives me, well, 45 and 45 gives me 90, so I know that 44 and 46 is going to give me 90. So it's, sorry, so again, I keep making the same mistake. This should be 90 subtract 46, obviously. Okay. Because I've already got my 90 degree angle. So 90 subtract 46 is going to give me 44. So there we go, there's our missing angle. Fill that one in, like that. Okay, so now I've got all my angles, I now need to find my missing side lengths. Well, let's choose this 44 and say we're going to use the opposite and try and find the adjacent. So what do I use for that? The tan of 44 degrees is the opposite. Well, the opposite is 10. Okay, so we're using this one here. The opposite of the 44 degree angle is 10. And let's call this then C. Okay, so tan of 44 degrees equals 10 over C. Now what I'm going to do is multiply then by C and divide by tan of 44, which means I'll get C equals 10 divided by tan of 44. And let's just immediately do that on the calculator. So if I write tan 44, if I type in tan 44, I get 0.9656 ... 0. What did I say? 9656 ... Okay, well, if I again use my calculator to do that calculation, I've got 10 divided by 0.9656, because that's to a reasonable degree of accuracy. I end up with C being 10.3562. So I'm going to round to 2 decimal places, so 10.36. Okay, so let's erase this and write this length now as 10.36 to 2 dp. Okay, now how do I get this one? Well, a number of different ways. I'm going to use this 46 degree this time. So I've got my opposite that I'm trying to find. Let's call this, should we call it X this time? Okay. So my unknown value now is X, and that's opposite the angle that I'm going to use. I'm going to use my 10 again because that's a nice number, and the 10 is adjacent to the angle, so I've got opposite over adjacent. In other words, I've got tangent again, so I'm going to have tan of 46 degrees equals, I'm running out of space here a bit, but should be able to put it in, X, which is the opposite, divided by the adjacent, which is 10. Okay, So again, if I rearrange this a little bit, multiply both sides by 10, divide both sides by 46, I'm going to have x equals 10 divided by tan of 46. Well, tan of 46 is what? Use my calculator. 1.0355. Here we go. Sorry, not naught. Remember that the tangent function, interestingly, goes above 1. So 1.035. Like that. So 10 divided by 1.0355, just to keep the accuracy, we end up with a value of 9.6571 ... So I'm going to call that 9.66. Okay, so x equals, let's say, 9.66 to 2 decimal places. Okay, that's that one done. Oops, okay, so let's just put that back in. Okay, so the last two problems here should be fairly straightforward because luckily I've got a 45 degree, which is going to be straightforward here, and a 75, which is not going to be so straightforward. I'm going to have to think carefully about how I do that one. But 45 degree is very straightforward because a 45 degree triangle gives us a second angle of 45. So in other words, it's an isosceles triangle. These sides would be equal. It doesn't look it in the diagram, but it's not drawn to scale. So I know that this side length is 3. I can fill that in straight away. And if that's 3, then by Pythagoras, I know that, let's use c because let's put it here. Okay, so c squared equals 3 squared. Well, let's just write 3 squared plus 3 squared. I suppose you could say 2 3 squared, 2 times 3 squared. But that's going to equal 9 plus 9 equals 18. Now, c, therefore, equals square root of 18. But square root of 18 is the square root of 9 times 2. Let's just complete that. Okay. Equals, well, square root of 9 is 3. So 3 root 2. So c equals 3 root 2, and that's completed problem E. We've got 3, 3, and 3 root 2. 45, 45, and 90. Now finally what I've got is an interesting problem here because I know, well, immediately I can fill in my angle, 15 degrees. Don't need to do a subtraction to work that out, but just to check, 15 add 75 is 90, add 90 gives me 180. Now, if I want to say, for example, what's this length here, let's call it y, then I'm looking at the adjacent side to 15 degrees and the hypotenuse, which is opposite the right angle, like that. So I'm looking at the cosine function, cos of 15 degrees. I happen to know that the cos of 15 degrees, which is going to equal the adjacent, which is y, over the hypotenuse, which is 11, the cosine of 15 degrees, it has an exact form. So I can write that as root 6 plus root 2 divided by 4. Because normally we think about the base triangle as being 4, root 6 plus root 2, and root 6 minus root 2. Well, I'm going to divide by 4 to get my cosine value. So that gives me y equaling 11 times, let's just put it here because we're not going to have much room, 11 times root 6 plus root 2 divided by 4 equals y. So if that's the case, then I'm pretty much there. I don't have to do much more. I might want to get rid of these brackets, so I think I should write y equals, distribute the 11 then across the root 6 and the root 2. I'll get 11 root 6 plus 11 root 2, all divided by 4. But it won't simplify any further because root 6 doesn't have a square that I could pull out. Root 2 certainly doesn't. So my answer is that y is 11 root 6 plus 11 root 2 divided by 4. Now you might want to convert that to decimals, which would sort of look a bit more sensible. Let's have a go. 11, okay, times root 6 plus 11, whoops, you see that's a bit tricky. Okay, I need to move out here of my root sign, so there we go, 11 times root 2. Okay, I need to put brackets in, so I'm making sure that the calculator understands exactly what I need to do, and then I'm going to divide by 4. Divide by 4. There we go. And it's written it in exactly the form I've got there. 11 root 6 plus 11 root 2 divided by 4. Now if I press my SD button to convert to decimal, what do I get? There we go. Equals 10 point, well, let's say 6322 dp. So it's approximately 10.63, but it's exactly 11 root 6 plus 11 root 2 over 4. So I've given both values there. That really does give me a very thorough value for y. What about x? Well, I'm not going to bother with the calculator this time. X has got to be 11 root 6 minus 11 root 2 divided by 4, and let's leave it at that.